We are starting with the parabola. We're starting with the parabola, guys. So for a parabola, guys, we will look at 4 or 5 ways in which it can be brought, in which the questions could be asked. But the main formula for the parabola, we have 3 main ways of writing the formula. So let's look at those. The first one is the one where it shows to a, x, and p, and q. So for this one, we have p and q. P and q are the coordinates of the turning point, and a will show us, um, will tell us how wide the graph is, and also if the graph is concave up or concave down. We will discuss those. Okay. The second part is y equals to a into x minus x1 to x minus x. So here a, we know what a is from there. X1 is the x value. X1 and x2 are the values of the x-intercept, the x values for the x-intercept. So x1 and x2 is where the graph will cut the x-axis, and y and x is just any point on the graph. So if you have one coordinate on the graph and you know the values of the x-intercepts, you can solve for a as the equation. But 3 y equals to, so this is the standard form we know, ax squared plus bx plus c. So what do we know about this one? We know that c is the y-intercept. C, the value of the y-intercept when x is 0, y is c. And b will help us find the x value of the turning point. Alright, guys. So these are the 3 ways of the equation. So we will start with this one. I've divided this into parts. So a quick summary of what we spoke about. A. So we need to know that if you have an equation and the value of a is greater than 0, a is positive. A is positive. Then the graph will just the okay, the graph will smile. No? Graph is smiling. It turns up. Concave meaning it curves. So this curves up, and if a is less than 0, meaning it's negative. That is, then the sad face. The graph is sad, it's down. Alright, guys. So you need to know if you see the value of A being positive, automatically you know the graph is gonna look up. Negative, gonna look down. If A is positive, but when you do your when you solve your equation, find you end up with A being negative somehow, but the graph is like if the graph is looking up, but when you solve find that A is negative, then you know you made a mistake somewhere because those two do not correspond. So the graph is they give you a graph and it's looking up when they say solve and find the equation, you automatically should know that A is going to be positive from A. Let's go on. So we'll start with part 1. Part 1. Part 1 is y is equals to a to x minus, oh, what I've done, minus square plus 2. Part 1. So we are saying here, if you need to solve for A, find A, need you need the coordinate of the turning point. TP is turning point, meaning you need the value of P and Q, you know, and you need also, look, if you have P and Q and you need to solve A, you need also one coordinate so that you have to put X and Y, right? So that A becomes the only unknown. You also need one more known point, one more known, point on the graph. Point graph. So if you have the coordinate of turning point and you have one more point, uh, then you can find the value of A. Find the value of A. So let us look at an example. Example 1. So for example 1, I'm gonna use the mother graph. I'm gonna use the mother graph. So remember when you did the exponential, we had a graph that didn't have p and didn't have the shift. We said that is the mother function because it does not have the vertical and horizontal. So here, the mother graph is a graph that tends on the origin. No, tends on the origin. The turning point is on the origin, on where the x at the center of the Cartesian plane. So meaning T and P are 0. That is a mother graph tends to the n are 0. And anything else proceeds from. So let us look at first example. So for the first example, uh, they given a graph. Oh guys, forgive me for that. I went far on the side. All right. So that is y. So let's choose the point there, 1, and this is 0. So let's say this coordinate here is 2 and 4. So on this graph, you see what we have. We have the turning point. What is the value of the turning point? The coordinate of the turning point. Turning point. What? 0 and 0. Right? And let's call this B. And B and B is 2 and 4. So we have the coordinate of the turning point, and we have one extra coordinate on the graph. So let us find the equation. Let us find the equation. We're going to solve that. So we start first by finding the value of A. No? Y equals to A into X minus squared plus Q equals to just not equals to. I want to use this space, guys, because I realize this space is not enough. But let's try. See. So y and x, they come from that extra coordinate. Y is 4 plus A into X is 2 minus P and Q 0 and 0. 0 plus 0. So guys, you see here the graph is looking up, so we expect A to be positive, right? We expect A to be greater than 0. So here we have 4 plus 2 A into 2 minus 0 is 2. 2 squared is 4. So A into 4. So we have 4, 4. Therefore, divide both sides by 4. A equals to 1. Right? So we have the value of A. So we can write the equation. So A equals to 1. So 1 into X minus P. What is the value of P? P is 0. There. Is here. And Q plus Q. What is Q? Is 0. Therefore, Y equals to 1. Remember guys, 1 I cannot write it because we know it's there, so even if I don't write it, okay. So Y equals to X squared. X squared. There you go. So this is the other function. It does not have B, it does not have C. Meaning, if it does not have B, this tells me that it will not have if it does not have B and C, that tells me that it will not accept the graph at any other point than the origin, because C is 0 and it accepts the X intercepts are also 0. So I see that here. So this is the mother function. Okay, let's do another one. Let's take another example. One that has been Okay, by the that's one and say graph, and let's say in point T. Let's say T is isomorphic, that's why TP is 1 and negative 1. Say 1 and negative 1. And we also have another point here, the y-intercept. Let's say it has the graph like negative 3, right? So we have two coordinates. We have the coordinate of the turning point, and then we have one extra coordinate on the graph. So I'll write them nicely here. This 1 and negative 1, and another point is going to be, let's call this one C, for example. C is going to be 0, negative 3. So we have these two now called y equals to a x minus squared plus 2. Know this is p and this is 2. Okay, so y is negative 3 equals to a into x is 0 minus p is 1 plus 2 is negative 1. There we go. So now I just have to call for a. Negative, when I bring it inside, it becomes positive. Okay, that's 1 equals to a into negative 1 squared becomes positive 1. No, just put in the bracket equate it becomes positive 1. So this is 2 equals to a. Therefore, a equals negative 1. So you see this, guys, a is negative. We expect it to be negative because the graph is looking down, right? So now that we have the value of a, can solve y equals to negative 2, that is the value of a, to x minus p is 1, where and q is negative. So plus, this is going to be negative, this is going to be negative 1. So this is the if they want you to simplify this or expand to new x equals to, so you just expand that minus 2, expand that part, x squared minus f plus 1 all minus 1 multiply everything by 2 becomes negative. X plus 4 x minus 2. So here y equals to, so this negative 2, 2 negative 1 becomes negative 3. So minus 2 x squared plus 4 x minus 3. So this is the equation. They want to write it this form ax squared. Okay. So from here we can see the value of the y-intercept is negative 3. It should correspond with the graph. There you go. The y-intercept is negative 3. When x is 0, this part becomes 0, part becomes 0, the remaining with negative 3. There you go. So the graph this equation is correct. So this is for part 1. You are given in point and one other coordinate. Let's go to part 2. Let's start with part 2. Part 2, y equals to a into x minus x1 into x minus x2. I've already explained that you need to need coordinates of x intercept. Need coordinates of x intercept, and you also need one coordinate, one known coordinate, one known point on the graph. So you need the coordinates of the x-intercept plus one extra coordinate, one known point on the graph. Right? Let us do an example of this one. One. So let us have a graph x. Right? So here the x value here is 1. I'll call this one A, and this one I'll call it B. The x value here is 1, the x value here is 3, and the y value here is 3 as well. So I have the coordinates of the x-intercept, and I have one extra coordinate on the graph. It can be any other coordinate, it can be anywhere this extra coordinate. Here's what I choose. Okay. Right? So the coordinate of A, 1 and 0, B, 3 and 0, and for this C, 0 and 3. So let us now solve. So y is equals to A into the x minus x1 into x minus x2. So the equation, guys, is this one. So from that extra coordinate, we're gonna substitute x and y. So y is 3 plus A into x is 0 minus x1. x1 is the first intercept of x. x1 is 1. See where the x-intercept, x1 is 1 from A there. 1, 2. Then x, remember I said it comes from the coordinate, x is 0. See, this is x, this is x. It's the same thing. This one is x1, this is x2. They're different. So x is 0 minus x2. x2 is the second x-intercept is 3 from that from B, where x-intercept 3. So from here, 3 equals to Remember, it's looking up, we expect A to be positive. A 2, 0 minus 1 is negative 1, 0 minus 3 is negative 3, 3 equals to A. Negative 1 multiplied by negative 3 is 3. Divide both sides by 3. Therefore, A equals to 1. Positive. See, the graph is up. So from here, we can write the okay, y is equals to, then you substitute A, okay, x minus x1 is 1 minus 1 into x minus x2 is 3. Okay. So this is the equation. If they need you to expand it further, then you'll do that. One is that is just 1, so leave it. So I'll expand everything in the bracket. No. This by that, x by x is x squared, then x by negative 3 is negative 3 x, and then 1 by x is x, negative 1 by negative 3 is positive 3. So I'll just simplify that. Therefore, y is equals to x squared. So these are the like terms, I group them together. 3x and x, this is negative 4x. Negative 3, negative 1 is 4x plus 3. There you go. So from here we can see the y-intercept is 33. When x is 0, y is 3. There on the graph corresponds. When x is 0, y is 3. That is correct. So this is how you solve part 2, guys. You need the coordinates of the x-intercept and one extra point on the graph for you to find A. After finding A, then you write the A. This is part 2. So let us move to the last part, being part 3. Part 3. Part 3, guys, is when you are given standard formula for quadratic equations. Ax squared plus bx plus c. And we know what c is, right? C, the y-intercept there, y value, y-intercept. We know that when x is 0, y is c. We've seen it on the previous that I did. So let us look at an example. E.g., let us call this point C, then this one, call this 1. Okay, let's call this A. Let's call this one here E. No, these are the x-intercept. And then this point here is what? It's TP. The turning point is where the graph ends, right? So you are given the equation of the graph. Y equals to, let's say the equation of the graph is f of x is whatever. Okay. Let's write it like this. F of x equals to x squared minus 5x plus 4. So let's say this is the equation of this graph. A is positive, that's x squared minus 5x plus 4. So 1, so they say find, for 1 they say find the coordinate of A, coordinate of B, and the coordinate of C. But 2 they say find the coordinate of the turning point. Number 3 they say find the equation of symmetry. Find the equation of symmetry. So let us start with A, B, and C. I will do it. Create space here. I'll start here for A, right? For A and B. So let's start with A and B. Why do I want to start with A and B? The reason I associate A and B is because they are both the x-intercept. X-intercept. So for x-intercept, what do? We let y equals to 0, right? Y equals to 0. See, let y equals to 0. Then we're gonna solve. So from the equation, we're gonna let y equals to 0. So 0 equals to y tends to 0. So it's 0 equals to x squared minus 5x plus 4. Then we're gonna solve for x. So we need the factors of C that give us the middle term. We need two values that when we multiply they can give us this value, but when we add them or subtract them they give us this value. So this is -5. So we need values that when we add them we can get -5, but multiply them we get 4. So here it's what? -4 and -1. So when you add -4 and -1 you get -5, but when you multiply them you get 4. So x, gonna write the factors in parentheses. So this is x minus 1 and x minus 4 equals 0. So x is equals to 1 and x is equals to 4. So a 1 and 0 is 1 and 0, and b is what? 4 and 0, right? That is it. Then we go to C. For C, that is the y-intercept. So for y-intercept, we say let x equals to 0, right? So y equals to, we let x be equals to 0, we solve for the y value. So from here it's going to be 0 squared minus 5 times 0 plus 4 equals to, so this is 0, this is 0, so we 4. The y-intercept 4. Therefore, the coordinate of C is 0 and 4. There we go. So we have A, B, and C, right? So we're gonna proceed to other question. So we want the turning point. So for the turning point, you first need to find the value of x. Then you're gonna take that value of x and substitute on the equation and find the value of y. So the equation is x equals to minus b over 2a. So x equals to minus, so b is this value, right? So what is the value of b here? It's negative 5. So this is going to be negative 5 by 2 into, what is the value of a? It's 1. A is 1. See, A is 1. Here, nothing, so A is 1. So x equals to negative to negative gives us positive. So that is 55 over 2 times 1 is 2. So x is 5 over 2. So meaning the x value here is 2.5 for the turning point. Now you're going to take that x value and substitute it in the equation for finding the y value. So y equals to x squared 5 over 2 squared x over 2 squared minus 5 into x, which is 5 over 2 plus 4. Therefore, y equals to, so you're going to punch this on your calculator and you're going to get the value of y. So the value of y, is going to be negative 9 over 4. 9 over 4. So you have x and y. So coordinate of the turning point between is 5 over 2 and negative 9 over 4. That is coordinate of the point. Okay, question 3 say write down the equation of symmetry. So when they say the equation of symmetry, they are saying, you remember guys what is symmetry is. Remember I told you that on hyperbola, the symmetry line is a line that you can reflect half the graph and then you get the same half on the other side. So even on the parabola, it works with the same theory. You need a line where you can reflect half the graph about that line and get the same half on the other side. So here the point of symmetry to parabola is on the turning point. It's a line cutting through the turning point. See this line. If I reflect this half about this line, I get this half. If I reflect this half about this line, I get this half. So the reflection line is this line that passes through the vertical through the turning point. So we need the equation of this line. So this line is going to be cutting through the x value of the turning point. See, it's a line that cuts the x value of the turning point. So you just need to know the x value of the turning point, and that is going to be equals to the equation of symmetry. So this one is the equation of symmetry. So we just say x. Let me x is equals to, then you look at the x value on that line. That line cuts the x. It cuts through the x value of it cuts the x axis on the same line as the turning point. Understand that? It's gonna go through the turning point vertical. So the x value is the same for the turning point and that line. So x equals to what, guys? What is the x value of the turning point? It's 5 over 2. So x equals to 5 over 2. There we go. So if we make a straight line x equals to 5 over 2 there, and select half of the graph about that line, we will get the same half on the other side. So that is the game of symmetry. So that is like symmetry, same half on each side. So that is it, guys. This is the third part. So here they give you the equation. To solve for the x, to solve for the y, solve for the turning point, to solve for the equation of symmetry.